Hi, welcome to the 7th lecture devoted to observed significance level or p-value. And let us start with the formal definition. So, the observed significance level or p-value for a specific statistical test is the probability of observing a value of the test statistic that is at least as contradictory to the null hypothesis and supportive of the alternative hypothesis as the actual one computed from the sample data. Of course, assuming that the null hypothesis is true. If you seek for a less formal definition, then you can say that p-value is equivalent to the value of alpha, which, as you remember, is the probability associated with type 1 error. The difference is that alpha is something we assume for the purpose of testing statistical hypothesis, and p-value is something we observe empirically. So basically, p-value tells you at which level of alpha you can reject the null hypothesis. So the procedure is very simple, although it's not that similar to the procedure of testing the hypothesis we discussed in the previous lecture. So first of all, you have to detect p-value. If you perform two-tailed test, you have to multiply it by 2 because, as you remember, in case of two-tailed test, we analyze both sides of the distribution. Then you have to compare the obtained p-value to the highest value you can tolerate. And finally, based on p-value, you can reject the null hypothesis or report on the lack of evidence against the null hypothesis. So, of course, formally speaking, p-value can take the value between 0 and 1, because this is the probability, but there are some common p-values we use for the sake of testing statistical significance. First of all, test statistic can be significant at 1%, 5%, and 10% significance level. We are commonly using those notations when we report test statistic. So you typically report it together with p-value. So if p-value is lower than 1%, then the null hypothesis can be rejected at the 1% significance level. If it is higher than 1% but lower than 5%, then the null hypothesis can be rejected at the 5% significance level. And finally, if it is equal to 10% or smaller than 10%, then null hypothesis can be rejected at the 10% significance level. I want to underline that, of course, everything significant at 1% level is also significant at the 5% and 10% significance level, but I believe this is quite obvious. So basically, we are looking for the lowest level of significance. So what you can find here is basically the rule of thumb. So there is no theorem saying that we should analyze p-value based on 1%, 5%, and 10% level of significance. So this is just conventional way to report the result of statistical inference. Typically, in most cases, when it comes to medical research or psychological research, we are interested at 5% level of significance. So using terminology we already discussed earlier, it's the highest p-value we are going to tolerate. But again, it's not a rule, it's just what I'm saying based on my own experience. When it comes to the results of econometric research, typically we consider 1%, 5%, and 10% significance level, but this is something we are going to discuss later. So, yeah. Okay, so actually that's it when it comes to introduction. In the next video, we are going to analyze how to calculate p-values for T-student test specifically. So thank you for watching.